Hi guys, welcome to my channel. Alright, today we're going to discuss about submersible pump. We are going to design a schematic diagram to control a submersible pump by adding a flow switch. We're going to incorporate the system with a flow switch, okay? Something like this. This is a flow switch. We're going to integrate this with a flow switch so that the pump can be working automatically, right? Then there's another pictorial view of a flow switch. This something like this again. This is the composition, how the internal composition looks like with a limit switch and a rolling ball. Okay, so we're going to integrate a circuit now by adding this. So let's continue. But now the essence of displaying this particular pictorial view and this wiring diagram is to enable you, because it's always a good practice for you to understand a process, functional process, a working process of a particular device. You have to understand it before you advance on it or before you alter the existing wiring setup or composition. So let me walk you through the wiring diagram first. This is my supply. Okay. This black conductor is our live conductor. Please take note. We have changed the wiring color code. Color code is no longer bearing neutral for live neutral conductor. Our live conductor is now black for line 2. All right. Line 1 is brown. Line 2 is black. Line 3 is gray. Then neutral is blue. So when you see this black is not neutral, please. Neutral is blue. That is this one. So let me walk you through the wiring diagram. Black now come to switch. This is the type of switch. I'm referring to this starter, the wiring diagram of this starter. Okay. This is the live conductor. Go to my switch. From switch to overload. From overload to motor. And this is the neutral. The neutral go to switch, another pole of the switch. Coming out, go to capacitor. From capacitor to motor. All right, the pump. Then there's another third cable coming from the pump and go to capacitor. We call it capacitor permanent. From the winding formation of this motor, after the winding formation, after the wiring and the connection of the windings, we have three conductors out to terminate to the terminal. That is this three conductor. One of them is live conductor, which is this one that goes here and supply. The second one is the neutral. Then the third one is capacitor line, capacitor permanent. One is capacitor line, one is capacitor permanent, and one is line. Line is this one, goes direct. Then neutral also go here and supply. Then the capacitor permanent come out from the motor and remain here. Okay. So let's design a circuit um, to control the small pump by adding a flow switch. Okay. So let's start by bringing our supply. This is our supply. Then we also have a breaker to protect the pump from overload and from a short circuit. After that, we have a switch here. After the switch, I have overload. This is my overload. Okay. I also have a capacitor. Let me also put capacitor here. Let this one shift a little. All right. Then the motor. This software does not have single phase motor with capacitor, but I'll use this one to represent the single phase with capacitor. Okay. So let's see how, let's just now do the connection. Then after you make reference to the one I just showed you, okay. Remember, this is the supply. You go to the circuit breaker to protect from short circuit. From there, you go to the switch. From switch, take note, the starter does not come with breaker. You have to add the breaker during the installation. Let me show you again. During the installation of this particular starter, you have to provide a breaker by the side. Supply your conductor to this breaker. The output of the breaker you feed the starter. Okay. And another one again, the power rating, current rating of this one must conform to the motor current motor rating. Okay. Then this one will go to overload. Then from my overload, I supply the motor. That one has gone. So starting with the second line, neutral come to the switch. From the switch, go to capacitor. Then from capacitor, you come out, you go to motor. All right. Then the capacitor permanent I told you about will now come out and go to capacitor this way. Right, we are done. So the next one is to earth the motor. We have a provide our earthing system here. All right, then all right. So this is the conventional method of this is a conventional method. Let me just show you once more. Uh, Take a look. Line go to switch to overload to pump. Neutral go to switch to capacitor to pump. Then third cable coming from here will stop at capacitor, like capacitor permanent. All right. So we are done with that. So now whenever I want to integrate this, let me show you the pictorial view of this. Now, whenever I want to do this by incorporating a flow switch, take note, this limit switch, the composition of this flow switch is a limit switch. Okay, if you open here, you're going to see a limit switch and a rolling ball. Now what I want you to do is that ensure that you don't connect this cable directly. See what I mean by directly? You don't connect the cable of the flow switch direct and allowing the flow switch to determine the current carrying capacity of this motor. What I mean is this. Let me, for instance, this is my flow switch. If I have this as my flow switch and I have a cable, don't do this by taking cable from here and cable from here, and this is your flow switch, and use it to now integrate this place by taking away this and put it here and return back here. So that flow switch will be closing and opening to determine the current. So in that case, the load will pass through here and go to the flow switch and come out and now power your motor. No, that is a very wrong practice, please. Take note. The reason is this. You must interface this with a contactor. So the flow switch will activate the contactor. Contactor now close and supply power to the motor. The reason you must not do it direct, you must interface with contactor is because you cannot ascertain the current carrying capacity of this. This is just a limit switch. From the nameplate, from the manufacturer nameplate, they might write 30 amps or 20 amps or thereabout, but you cannot ascertain the current carrying capacity of this because it is enclosed inside. It is embedded. You cannot ascertain the quality of the material composition. So because of that, don't rely on this. So what you need to do is to interface a relay or a contactor. Then this particular one will activate a relay or activate a contactor. Contactor now take the load for you. Okay. Like for example, look at this. This one is rated 20 amps, but you wouldn't know if it is really 20 amps. Okay, that is what I'm saying. So because of that, you need to interface this connection with a contactor or a relay. So we're going to do that now. I don't know if the video will permit us, otherwise we'll do a second video to complete the exercise. So let's do that. Now I want to integrate that. So employ the services of a contactor. Okay, so let me get a contactor. Put my contactor here. All right, this is my K1. All right, this is my contactor. Okay. Um, or let me give you the 3D of it. I think that is better. Let me give it, no, you look odd. Let's use the symbol. All right, now if I have this, so what I'm going to do is to create we're going to alter something here. That's why I want to use a dotted line. Okay, we're going to take this out. We're going to take this out. Then we're going to take this out again and take this out again. You are tapping cable. I'm using dotted line because to put on this pump, you have to on this. And to shut it down, you shut it down from here. Now it's going to be in closed open position. Why the flow pump will take over. This switch is going to be in open position while the limit switch operation will take over. When that particular configuration go bad,